folks, we can get started. Let me just pull up our stuff for today. Actually, it looks like we got a question. Okay. We got two questions by the same asker. We'll just go from top to bottom. Okay, removing dictionary keys. Challenge number 3. Oh, the sound is low again? Oh. Let me adjust that. Check, check, check. Testing, testing. I should do this every time before I start, because it looks like it's gonna respond a little different every time, so apologies for that. Looks like that's as high as I can push it this time. Yeah, I can't get it any higher than that. Not sure why it's so different every time. If I can see if I can get this closer to my mouth. Okay, I'll just try to speak up a little bit. Hopefully that'll be okay. Removing dictionary keys. Looks like we're working on the third challenge. And I'll copy in their code. Okay. And I'll pull in the copy here. Let me get Dark Reader on here. That's better. A little easier on my eyes for now. Okay, write a function called delete dups. Function should take in a dictionary as an argument. Should go through the values inside the dictionary and remove any key value pairs where the value occurs more than once in the dictionary. Okay, cool. I think I recently, that's funny. Oh, maybe I just didn't do it on this particular cohort or something. I'm not sure. Huh. Okay. I believe I solved this one recently on stream, or maybe it was with a student. But let's go through this again. So this function should go through the values. Okay. The values. Oops. Inside the dictionary and remove any key value pairs where the value occurs more than once inside the dictionary. This function should remove the second occurrence and third and fourth occurrences of the value, not the first occurrence. Okay. You should make a copy of the past dictionary. The dictionary method dot copy makes a copy of the dictionary is applied to. This lesson covers how to copy dictionaries and more. Okay, yeah. So let's first, before we start cracking on this, let's get a test together. I'm just going to do a little bit of, that'll need something. I think this was meant to be greater than or equals. have a little bit of a spacing issue. Just noticed this. It's probably just from when I copied and pasted it in. Okay. Okay. Good. Looks like we're good to go. So let's think of a test for this. So print, we'll take in my dictionary. Let's just call it data. We'll say data equals we'll say A colon 33 B colon 44 C D E F. Okay, so let's say B, D, and E are all 44. C is going to be 55. F is going to be 77. Okay, so what we want, since we have A is 33, B is 44, C and D are 44 as well. So the information that we should see removed are D and E here. Or I said C and D, I meant D and E. So D and E should be removed from this dictionary, which means we would expect data to be equal. After this function runs, we would expect it to return a dictionary with D and E removed. So our expectation should equal this dictionary. And let's do this. Let's say our result equals that. Then we'll just print result. And let's pop in our expectation up here. And we'll also print, res result equals expectation. And this will tell us true or false whether the two are equal. And if they're equal, then we know that the function is working correctly. Okay, cool. So we have a little test. We have our input data. We have our expectation. We have our result, which is just whatever this returns, and we're going to print that result so we can see it, and then we're just going to print if the true or false whether the result is equal to the expectation. Cool. So I did do a little bit of formatting to this. I fixed an error with this, but other than that, I think that was kind of an obvious one, but other than that, I think I haven't altered this code in any way, so let's just run it and see what we get. Okay, so this is a common error, runtime error, dictionary changed size during iteration. So what happened, we have D equals to the copy of our input, which is good. We have our occurrences. We loop through key value pairs in the dictionary with dictionary.items, and we check the occurrence, the number of occurrences. We count the value. We get the count of the values in the dictionary. one little superfluous thing. We actually don't need to cast that as a list. We can just count directly on values, I believe. Is that gonna? No. Oh. Excuse me. I was wrong. We do need to cast that as a list. Duh. So we get the count of the values in the dictionary, and if the number of occurrences of that value is greater than or equal to 2, then we're going to delete d sub k. So this runtime error is being caused by an interference between, let's see here, between these two, right? So d dot items, we're looping through d dot items, and we're also changing its size specifically by shrinking it. We're like shrinking it down. So what happens is the for loop advances to the next item in the dictionary until it finds something where this condition is true, and then it deletes that item. It's going to delete that item in the dictionary. So the question is, it deleted some number of future items in the dictionary. So the question is, what should the for loop do? What should its next or future iterations be? This error or this behavior, when you're deleting something that you're looping through, that you're running the iterator through, when you're actually deleting something from that thing that you're iterating through, if you think about it, like if you were designing Python, what decision should you make for how for loops should behave in this case, right? Does it loop through the old state? Does it just take a snapshot of the state and just keep looping through that regardless of how it's changing? Well, it could do that, but that could potentially be a very expensive operation. Imagine if the thing you're looping through is like 1 million records, right? In order to take that snapshot, you'd need to duplicate all 1 million of those records in order to make sure that you weren't, doing that, right? You'd need to essentially copy it, right? Which we're copying dict1 here, but the copy is what we're iterating through, and the copy is also what we're deleting from, right? So since we have a copy here, we can iterate through we can iterate through the original input, but delete from the original key. Or excuse me, let me say that again. I misspoke. We can iterate through, in the for loop, we can iterate through the original input, but delete from the copy. So that's one way to work around this. I want to show you another way to approach this problem as well. Okay, so A33, C55, E44, F77. So this does delete duplicate values, but it deletes all of them, right? Like it deletes, if a value occurs more than once, it deletes all of those values, right? So the value for B occurs more than once, and it occurs in D and E, right? So it's going to delete anything that has a duplicate value, not just the second or whatever past the first instance. It's going to delete the first instance as well. Okay, so how can we rectify this? So what occurs to me is to just create a list of values that your for loop has encountered before, and rather than creating a list of values as you accumulate, or as you go through the dictionary, just accumulating a list of values, and as that list evolves, what you do is you check, is the current value already in the list? And if it is, you don't need to append it, then you'll delete from the dictionary. So what I would do is say like something like values already seen list equals a list, right? This is going to be for values that the dictionary is already seen. I'm just for the sake of brevity, we'll just put that as a comment. Values already seen. Okay, we'll do it this way. A list for values already seen. So then, for key value in dict.items, we'll just say seen list dot append value. And then in our condition here, we'll say if v in seen list, I made a little mistake, I'll have to rectify that in a second. So if the value is in the seen list, then we'll delete d sub k. I actually need to move this down, so below that condition. So what I'm doing is an alternative to this occurrence scenario. So we'll just delete that. Oops. Okay. So let's see if that's going to work. Cool. So we see A, B, C, F are our keys. 33, 44, 55, 77. And it says true, so it must mean our expectation and our result are equal. So let's just verify that visually. A33, B44, C55, F77. Our expectation reads A33, B44, C55, F77. So that looks good to me. That'll do it. There's another way that I would do this so we don't have to iterate through dictionary 1. I don't even really like iterating through the input in this case because that input is still some object from the outside. So what I'm tempted to do is to say dict1 dot copy dot items, and then make d equal to just an empty dictionary. And I think this, what does this say? Removing key value pairs. So this lesson is about how to remove elements that are in a dictionary. What I'm going to do here instead is I'm just not going to add elements that are in seen list. So we'll say if v not in seen list, then we'll add it in, and we'll say d we'll say d sub k equals v, and that'll add something into our dictionary. So I tend to prefer additive solutions rather than subtractive solutions because I think they're easier and I think it makes my code more consistent. In my experience, they tend to be easier to think about, to invent, to reason about, and this is going to have basically similar behavior. Okay, and this is going to give us the same result. A33, B44, etc. We know that they're equal because it's true, right? Now this does, I am cheating because I'm not using delete. I'm not removing a key from a dictionary, but since we're using a copy here, we're using a copy of the dictionary or making a different dictionary with a different ID, then we can get away with this. Technically, we also don't need copy here. It'll work just fine like this. Cool. So I'll submit this and see if Learn likes it. I think it's a working solution. Like I said, I am cheating because I'm not using del. I'm not actually removing the keys. But you can see this. This is functionally identical, essentially. Right? Here in the example, they're going to say they have an occur list, which I think is just my scene list. And then we have our past and dictionary. We have our return dict, which is a copy. This says 4 pairs. It's interesting that they didn't do KV, but they just did pairs, and they're just indexing into pairs, which is going to work as well. So 4 pairs in past dict.items. If pairs sub 1 not in pairs sub 1 is going to be the value. So if pairs sub 1 is not in the occur list, this is the same exact line. It looks a little different, but it's exactly what I'm doing here. If v not in scene list, these two lines use slightly different naming, and they look a little different because of that, but they're exactly the same. Same thing is happening. Pairs sub 1 literally is the same as value. Then they say, so if it's not in there, then they will append to the pairs list, or to the occurs list, pairs sub 1. They'll append the value into the occurs list. Otherwise, they will delete pairs, the return dictionary at pairs sub 0. So this would also work. Cool. Okay, on to the next one. Another question here. Let me see if I can copy this. And we'll get their code. Which question? Challenge question number 2. Okay. Modulo Dict. Good, this is the one. Okay. All right. Okay. Write a function called Modulo Dict. This function should do the following. Take a single number as an argument. This number will be used in the modulo operation. It should calculate the modulus using the argument of every number from 0 to 100 excluding 100, which is the default behavior for range. Okay, so it's a regular range. The keys will be possible modulo values. The values will be the count of times that modulo value occurs. Here's an example of how the function should work. Great, we've got a nice little test here. So let's do this, print, oops. Okay, so this is going to print out our result. this is our expectation for this input, which is 2. Cool. Let's, I haven't done any modification to the code. I haven't even read it. Let's just see what happens. Well, this is very close. We got 0 is 50 and 1 is 50 for the expectation. This one just has 1 at 49, so I think probably we just have to move something around. This is for I in range n d equals an empty dictionary. That line won't be necessary, so let's just back this up here. This should run the same unless I'm crazy. Okay, so for num in range 0 to 100 plus 1, so the instructions say to not include 100, so let's try that. Let's do that. Okay, so this is going to get us to 49, 49, so we've actually got slightly further away here, but that is okay because I know that the instructions say to exclude 100, so we'll do that. I'm just going to do a little formatting so I can read this a little better. Okay, so for num in range 0 to 100, k equals num mod in. Oh yeah. Num mod in. Okay. If num mod in, not in d keys. Interesting. So why does this give us such a strange answer? It's so close. Okay. Some of you perhaps are seeing exactly what's going on here. It is escaping me at the moment. I think what I'm going to do is just comment this out and start over. Sometimes it's better to just start over. Okay, so I'm going to have my Modulo Dict takes in. We're going to say d equals an empty dictionary. We're going to say for I in range 100, print I. And we want to, let's just check in with this problem statement again. Function called, the function should do the following. Take a single number as an argument. This function will be used, or this number will be used in the modulo operation. Number should calculate the modulus using the argument of every number from 0 to 100. So that's the modulus using the argument of 0 to 100. Okay, so that'll be 0 over 2, 1 over 2, 2 over 2, 3 over 2. Okay, good. Keys will be the possible modulus values. The values will be the count of times. Okay. Oh, I see what happened. I see exactly what happened. Okay, I don't need to write this again. So I see what happened in the code here. What this is doing is saying we have our k, which is our key, equals num mod in, and this is good. It checks if k is not in the keys of the dictionary, and if it's not, it adds it in. But it initializes it with 0, right? If k is not in the dictionary, it does mean we saw k once, so we can start it with 0. And that will, or we can start it with 1 instead of 0. so that'll give us the correct answer. So just a one little thing here. It definitely does make sense to initialize things with 0 a lot of times, but there isn't quite like a hard and fast rule around that always needing to be the case. You still got to take it case by case, you know. So in this case, if key is not in the dictionary, we do want to add the key and a value in, but it does mean that we can count it because we've seen it once. So if you're going to have this else here, if you're going to have this else here like this, we can start it at 1. Otherwise, you can start it at 0. Then we can delete the else and then just do this underneath. And then basically this just is sort of a safety, right? Like sort of think about this differently. We can say if the key's not in the dictionary, just add it in and then move on. And then it'll just increment whatever the key is. And just so that this line doesn't get an error, we add it in if it doesn't exist. Cool. So this is probably how I do it. I don't know. Same diff. Cool. Let's submit it. Make sure Learn likes it. Okay, so we have a question about this. What about what Tovio mentioned in the cohort, that the dictionary does not guarantee order? You know, that's a good question. And I think this pertains to the previous question here. I know this to be the case about dictionaries. So this question, it wants us to delete like the second and third occurrences or whatever. I know that dictionaries don't guarantee order, so I don't know why this problem always works this way. I actually don't know why. So it seems to obey an order for this specific problem, and I'm not sure exactly why that is. My hypothesis is that dictionaries, if they're just initialized like this, are going to obey an order kind of loosely, and it'll just work on it on that basis. But I'm not exactly sure, to be honest. I just know you can treat them as if the order is preserved in that specific problem. But yeah. Okay, so it looks like it likes this. Cool. What is Modulo Dict? Please explain. Let's see. Did that answer your question for Modulo Dict? Let me know. Okay. And I do see we have another question. Okay. A couple more questions here. Compute product of all elements. Let's see where this is. Let's do that. So it says this is question 8. Having trouble with conditional statement. Okay. breakdown for for loops. We got a quick question for breakdown for for loops. I'm going to take this just quickly before I get into the nitty gritty for this, so that you can have some context for what we're going through. I don't want to spend a whole long time on this, but I'll go through this as quick as possible. So a for loop, the syntax for a for loop, we can just have the for keyword, and then basically a for loop is going to allow us to represent each element in a collection of elements, which we also call an iterable, right? That collection can be iterated through with a for loop, right? A for loop will give like different iterations through that collection of elements. A really common collection is just range, which just gives us a range of consecutive numbers. Simple range will just start at 0. If we give it range 10, it'll go from 0 to 9. So it'll go up to this argument that we passed to range, but not include it. So what we really want to do with a for loop with like this is go through this iterable collection and represent each element successively with an identifier, which is like a variable name. So we can name, we can give a name to what we're going to call each element, and that name will point to each element within the iterable one at a time. So it'll start at the first one, and then the loop will complete. The code within the loop will complete, and then it'll move to the second one, and the code in the loop will complete, and then it moves on to the third one and the fourth one, etc., until it gets to the end, and then the loop just stops, unless you stop it explicitly with a break or something. Cool. So we want to be able to name each element in this collection. So let's just say for number, I'll just call it num in this collection. So it says for number in the collection called range, with the range of 10, and then we can print the number, and you'll see that we'll be able to see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It'll be printed out on each line. Let me know if that helps, if that answers your question. I know that's not a super in-depth look, but at least hopefully that gives you an idea so that you can hang on with what we're talking about today. Okay, cool. Let's dive into this one. Write a function, compute product of all elements. Given a list of numbers, the function returns the product of all the elements in the given list. I think I know how to... This is going to be like factorial, except instead of running through a range, taking in a number and running through a range, we take in a range, or we take in an iterable and run through that iterable and still just take the product of it. So I think I can do this just exactly like I would do factorial. I'm just going to chase that out before I get into this code, but let's just see. Perhaps I'm not understanding this question at all, but it seems pretty simple. So if I give it a, like, let's say a list of 3, 4, 5, print 3 times 4 times 5. We'll just run that really quick. So that should be 60. So I think I should expect 60 for here, for this. Okay. We're getting 0. So really quickly, I'm just going to chase out my hunch here. I think we can just do prod equals 1. For num in ARR, which is short for array, that's our argument here. So for num in the array, prod times equals num, and then return prod. I think that'll do it. Cool. Let's just see if learn takes that. And I'll try to look at the original code as well and see if we can get that to work. Ah, it doesn't like that. So I must have misunderstood the problem here. Oh, interesting. So 2, 5, and 6. That's extremely weird. 3, 4, 5. Huh? Let's try this. 2, 5, 6. I don't know. That's supposed to be 62, evidently. Or 60 as well. That's also 60. Well, I don't know what I did. Okay. Well, let's see here. Did I miss something? Notes. Okay, here we go. If the given list is empty, it should return 0. Ah, okay. If not any non-numeric values exist in the list, it should return 0. So these are some edge cases that I'm not handling. Okay, let me actually read through the original code here. So we have our accumulator. This is handling that edge case. If the length of the input is 0, we're just going to return 0. That's good. That should do what we want it to do. For num and array, that's what I had. If type of num not equal int, or type of num not equal float, we can just do this really quick. Shorten this a little bit. We'll do a test for membership. It'll allow us to do multiples. If type of num not in int or float, then return 0. ACC times equals num. So that gave me 0 before. I don't know. I do not know. What did I change? Why isn't that working? Well, that's really interesting. Would you look at that? Somebody's asking which problem am I working on now. Let me just get a link to this really quick. This is the eighth challenge at this link. Oh, somebody already got it. There we go. Yeah, the 8th challenge at that link. Okay, cool. So let's see here. So what I'm curious about is why this works. Oh. I wonder if it's this. It's really taking a while to run here. Float. Wow. I do not know why that isn't running. That's extremely weird to me. I have no idea. Let's just try this. Okay. Okay. Each of those conditions works on their own. So, if the type of num is not equal to float, or num, I think there's probably some just funky thing going on where the logic like isn't what you'd think it would be, like intuitively. Like if we actually, I bet that's it. This condition is blowing my mind. Because that definitely seems like that would work. I don't know. In general, if I need to see if something is one of multiple types, I just do a test for membership. I throw those types in a list, and I just say if, in this case, I'll say not in. So if it's not in this list, it means it's not one of these. So that will work. I am really curious about that other bit of code, though. I want to solve this mystery. Okay. I think what we're going to do here is just use this and just look at it in isolation. But for now, that should be working code. Yeah, that's working code. Let's see if Learn likes it. Correct. Okay. Whatever. I am so curious about this though. Oops. Let me grab that original line. So let's grab this. Okay. Let's just look at this and let's try to figure this out. Because I'm sure we can figure it out. So let's just do something. We'll just print this off and we'll see if it's true and we expect it to be true or what. We'll say num equals 10, which is going to be an integer. And we'll just print this off. So what do we expect from the statement type of 10, which is int, not equal to int, or type of float not equal to float? Oh. Right, so we expect false here. but it's true. Am I crazy? We expect false, right? False. Let's just do each of these on their own. Okay. So these two I get on their own. It's not equal to it. Its type is not equal to float. And its type, so that should be false, or that should be true. Oh, that's right. It's so obvious. It's so obvious. Okay. Why? I don't know why it has to be that obvious, and I had to go through these links. Okay, let's break this down. Okay. Or let's just look at really simple or statements. We'll say or true, true. Okay. So or gives back true when either of its inputs are true. When either one of its inputs are true. So if we put true and true into or is going to give back true. If we put true or false, it's going to give back true. If we put false or true, it's going to give back true. If we put false or false, that's the only scenario where it will give back false. Right? So what happens is when the type of num is an integer, so type is an integer. So when we have an integer not equal to an integer, obviously an integer is equal to an integer, so int equals int is true, int not equals int is false. Whereas the type of, if we have an integer not equal to a float, then that's going to be false, because it's true that an integer is not equal to a float. So this statement, or this expression, gives back true, and the or has a true. We've gone into this scenario, false, true, which gives back true, which means we return 0. That's why that is. What a weird one. It's like obvious now, but it's like it also feels weird, because when I read this, it makes sense in English. It makes complete sense to me in English. So I wonder if it's just an and is what we needed. So I think we can change that to an and it would work as intended. Although I think it kind of reads strangely that way. So I think it's because it's sort of, we're doing like a double negative thing. So if we change this line to this, if type of num not equal to int and type of num not equal to float. That's what it is. So if it's true that num is not an int and it's true that num is not a float, right? And the only things that would be true for are things that aren't either an int or float, right? So we want something that is not an int and not a float. So a string would be string not equal to int is true and string not equal to float is true. So that needed to be an and instead of an or. That's so funny because it seems so intuitive the other way. Yeah, so that's an example. So I think this code would work as well. Let's submit it. I just changed it from my check for membership, which is my, I don't know, my preference for something like this. I like it. But let's just check it out and see if the and is going to give us what we want. That's going to work too. Cool. All right, we've got another smattering of questions. Hopefully you're good on that to question asker there. It seems like we have some follow-ups. Would I be able to go over question 4, presumably in the same section? Yes, give me a link to it anyways, so I can come back to it, but I have another question ahead of you. Okay. Apologies, due to regulation reasons, I'm avoiding saying people's names on stream, but I will post the person's name whose question I am currently working on. I will post it in the basic prep channel, since everybody who's in there can already see that anyways. Just want to keep some level of anonymity for YouTube, which just is a little more public than this. So there are regulation reasons why we're doing this, just kind of staying on the safe side of things. So sorry if that makes it inconvenient or something, but yeah. So I just added the person who I'm whose question I'm taking currently. So let's look at this. Come on. There we go. Oops. Okay, and this is going to be, can we go over to a solution to this? Which question is it? I'm going to have to find the question based on the code. Let's see. It gave me a whole doc string and a whole thing here. Looks pretty good. Cool. Okay, so this is the code provided. So let's see what it does. Looks like we've got a test here, which is great. I see I've rubbed off on you. That's great. Okay. So we have a dictionary. Wow, this is a really interesting dictionary. What is going on here? What a weird... Oh no, this is a set. Oh, of course, that's a set. All right. It always wigs me out that sets and dictionaries both use curly brackets. I'm always like, what's wrong with this dictionary? It's like missing values or something, but it's just a set. Okay, so write a function called remove or add that takes 2 values. The first parameter will be a set Okay. That takes two arguments. The first, oops, let's do this. The first parameter will be a set that will have an unknown count of numbers or letters. The second parameter will be a list that also has an unknown count of letters or numbers. If a value in the list is not also in the set, it should be added. If the value is in the set, it should be removed. Oh, wow, okay. So let's look for remove or add here. Okay. Looks like they got the test here. That's nice. Cool. Write a function called add or remove. Takes two values. The parameter will be a set. Da da da. Okay. This is just what we just read. Okay. Let's just start going through this. So what I'm curious about, what this doesn't quite say, is if the value if a value in the list is not in the set, it should be added to, presumably, to the set. So, yeah, if the value is in the set, it should be removed. Okay, so we go through the list and we see if an item from the list is not in the set, then we add it. If an item from the list is in the set, then we remove it. Huh. What are my set operations here? Discard. That's a candidate here. Okay, so we have add, which I know is similar to append. Clear copy difference. Okay, clear copy difference. Difference update. Discard. I'm betting it's discard is the one that's going to be used for remove. Then, of course, there's remove. So let's see. So my question here is, if I have a my set variable equals a set, let me actually do this up here, because I forget the how to. I don't work with sets that often, so I kind of forget which methods I have at my disposal. So let's say I have 4, 5, 2. And if I want to remove 5, so if I say my set dot remove 5, print my set, let's just try that out, see what happens. Okay. Does pop do the same thing? Yeah, pop doesn't Pop's not going to work. Okay, so dot remove will do it. I wonder if discard. I wonder what discard does. Probably going to get an error here. We'll see. Oh, discard works too. I'm going to use discard. That's interesting. If it doesn't work and I'm confused, I'm just going to change it to remove because that'll probably work. Okay. Let's just run this a few times though, just to make sure we're going to get consistent results. Interesting. It's always giving me the same order. So I do 7. I wonder if it's discarding the highest thing. Nope, it's discarding 5. It's discarding the thing that I tell it to. So if I can I discard 2? I can. Okay, good. Okay, good. That's proof of concept. I know add will work for adding things in. Okay, so for index and obj in enumerate the list, if object is set 1, what we want to do is check for membership. Like this. I'll just comment this out for now. Okay. So if the object is in set 1, what do we want to do? We want to discard obj. Okay, so 1, 2, 3 is in set 1, so that means we should remove 1 and we should add a. Okay. Here we should just remove 1. Oops, I forgot to print the result here. So now it has 2, 3, so that looks like that works. And then I think we can just do else. Because it's just it's a perfect negative case, right? Either the object is in set 1 or it's not in set 1. There's not a different state of it, being in set 1. It's either true that it is or it's false and it's not, right? So I think this is what we want to do. Let's just see if that's going to work. A23, that's what we expect, looks like. This gives me A23. Okay, so let's do a quick reflection on what I did here. Let me copy my code. I don't really, or actually I'll copy in the original code. Why don't I do that? Let's do a compare and contrast real quick, and we'll kind of break that down. It's happening in one over the other. Okay. So for one thing, we have discard instead of pop. I'm pretty sure this will, I should try to submit this before I conclude that it's going to work. I'll submit it into Learn. We'll see if Learn thinks it works. It's kind of more important than if I think it works. Good, it works. Okay, good. So I'm using discard here. I'm curious about discard. If you're ever curious about something, let's do this. We'll get a little space in our terminal here. And I'm going to run help set.discard. And I'm not going to invoke the function. I'm just going to pass the function uninvoked. This should give me documentation on discard. Okay. Help on method descriptor says discard ... remove an element from a set if it is a member. the element is not a member, do nothing. So what does remove do? I think remove gives you an error if it's not a member. Maybe I'm wrong. Let's look at this. Remove an element from a list. It must be a member. Ah. It must be a member. So I think we can use discard. So if the element is not a member, raise key error. Raise a key error. So remove will remove something, but it has to be a member of the list. But it has to be a member of the set. Discard will remove something, but if it's not a member of the set, then it's just not going to do anything. So that's interesting. So they are different. Not sure if it matters which one I use in this case. At any rate, I think you could use discard or remove. I think the example here has remove. Yeah, the example shows remove. I think it's basically the same code as my final solution here. But yeah, so I guess you could use discard or remove here instead of pop. I think pop well, let's look. Let's see set.pop. Let's see what pop does for sets. I'm familiar with it for lists, but I kind of think it just can't take an argument. So it removes and returns an arbitrary set element. So it just kind of picks whichever element in the set and removes and returns it. Raises a key error if the set is empty. So if the set's empty, we're going to get an error. Interesting. So I think that's the thing for pop. It's like you want pop to act like remove or discard for sets, which I mean it makes sense in the context of a list, but when we have a set, it's going to be different. So pop, when we use it for sets, I think just doesn't take an argument. So it's just going to remove an arbitrary element, just whichever one it wants to remove, and raise a key error. So this would be, I think, a kind of like semi, I don't think random would be the right word, but arbitrary, meaning just some element, whichever element Python decides you should have. So kind of unpredictable in a similar way to random. Cool. So I guess that's one difference. What else? I guess the other one is the conditions. So obj is set. What this is saying is that the object is the set. And I think, how can I demonstrate this? I think is, let's do this, like list equals a list of 22, 44, 55. And we'll call this list 1. We'll say list 2 equals list 1, right? So we're not doing a copy. Print ID list 1 equal to ID list 2, and we should see that this should be true because the IDs should be equal, which tells us that they are the same exact method, or the same exact object. I don't know why I'm like mixing up my words or something today. Okay. So let's try something like this. We'll say list 1 equal to list 2. This should also be true because the values, we didn't alter the value, so the values are going to be the same. Of course, the value is going to be the same because they are literally the same object. So at any given point, it has the same value as itself, of course. So so let's try this. List 1 is list 2. So that's also going to be true. So I think what essentially what is going to do is I believe it's going to check if it is literally the same object, like 174 here. So I think it's a little bit of syntactic sugar to see if the IDs are the same. But let's verify that by making list2 equal to a copy of list1. We'll say copy. So if it works like I think it does, the IDs are going to be different, the values are going to be the same, and list1 is list2 should be false because they're not the same object now. They're different objects. That's my assumption. We'll see. Yeah, and that's the case, right? So using is in this manner is going to check if they are literally the same object, which is exactly the same as line 174, where I'm taking the IDs and seeing if those are equal. So I think it just kind of cleans this syntax up a little bit, makes it a little cleaner and just easier to read. I think Python kind of does that a lot. They're just like, here's one way to do it, but here's like a cleaner, simpler, prettier way of doing it. So I'll include that in the notes there. Okay, so that's another difference. So we changed pop to discard, and we changed is to in. I think the idea was to check if it was the object was a member of set1 though, so it might have just been a simple typo or something. And then if obj is not presumably in, the way to write that would just be to say if obj not in set1. However, since checking if obj is in set1 and checking if it's not in set1, since this is literally just the negative condition, the perfect, complementary condition, we can just say else, and then I think we just have my code. Yeah, so discard in is to in, and then just an else there, which it would work the other way, but kind of I think it makes a little more sense that way. So for context. Okay. Somebody asked if I would go over question 4. Can you send a link to that question that you want to go over? That would make it easier for me to go over and just say this question, here's the link, here's the number, and then that way I'll know. Just put it all in one place is all I'm saying. Okay. Cool, we got another one, if I have time, number 17. This link. Hey, we got time for this one. Maybe one more, maybe two more. We'll see. Looks like this is the same one as before. We got this is all making sense. Few silly errors. Also, there is no reason to enumerate the list, correct? Yeah, okay, so this, we have a comment on the previous, by the original question asker for the previous question. Yeah, I actually forgot about this. I saw this and I'm like, I'm not sure this is necessary, and then I forgot about it because I wanted to come back to that. But yeah, I think this would work fine if we didn't enumerate, because you're not using, I don't see, yeah, I mean, you could get rid of it because you're not using the enumerate there at any point. Also, you know what? I'm tempted to do this in a different way. Just say out equals set, and then just add. So if the object is in dot copy, I think I need to do set1 dot copy. Yeah, that kind of makes sense. And then I can just do this. I want to see if this is gonna, if learn is gonna submit this, because this is a better way to do it, because then you're not altering this global variable that's passed in. Sorry, I know some of you are probably eager to move on, but this is kind of a good. Okay, that'll work too. So the difference between this and the previous code is that the previous code would change this set. So if I had my set and I said my set was equal to this, the previous code would have altered the value of my set and returned that value, in addition to altering this specific set. This code does not alter this set. It just it leaves it alone. It leaves it unchanged, and it just returns a different set. So, yeah. Okay. Now we're actually moving on. Where is it? Okay, list methods 2. Number 17. Let's go for 17. Okay. Get longest words. Da da da. Okay. Oh, we've got an error here included. So it says the error is max arg is an empty sequence. Okay. Okay, let's look at this. I bet I know what's causing this error. Write a function called getLongestWord of mixed elements. Given a list of mixed types, getLongestWord of mixed elements returns the longest string in the given list. Okay. If the list is empty, it should return an empty string. If the list contains no strings, it should return an empty string. The output of this should be that. Okay. Let's try that. So output equals that. Let's do this. My mixed list equals this list. I'll just pass that in there. Just kind of trying to tighten everything up, make this nice. Okay. So we have our list. So the longest word should be word. Let's do a couple more tests because we have some edge cases here. One was that there are no words. So let's see here. Let's just delete the words. Okay, so that one's only that, and this one is that. In this case, we should get an empty, oh, come on, an empty string in either of these cases. So my output that I expect is word empty empty string. And just so I can see the quotes, I'm going to put these two in square brackets, and that'll actually show me, I'm printing out a list containing that output now, but that'll show me empty string quotes rather than just printing lines with literally nothing on them. So let's just see what this does. I think we'll get that value error. Max arg is an empty sequence. Okay, so I think, oh, yeah. So this is an assignment. I am not sure. So this is where I see max being called. Let's see, yeah, 189. Max is being passed an assignment here, although is key, is that perhaps an argument to max? I don't know. Let's do help for max. Let's read about max really quick. Help on built-in functions max and module built-ins. So max takes in an iterable the default obj and a default key equals function. Wow. Interesting. What an interesting function head, function signature that Max has here. That's so very, very interesting. Huh. I never knew you could use Max in this way. Okay. That looks like that's valid then. Alright, so I'm just going to comment this out. I'm going to try to get that max code to work. We're just going to see if this error goes away if I don't run this last type, because that value error, max arg is an empty sequence. That value error makes me think that max is upset because it's being given an empty sequence, which is like an empty list, so go from there. List is not defined. ARR. I know I commented out list up here, but I just want to try it with something. I'm just trying to get this to work. Object of type int has no len. Oh, that's what's happening here. If array is empty, wow, that should be handled then. I don't know what that is. Oh. Huh. Yeah, I see. So for obj in array, if type obj equals string, then we append it to list. So this checks if array is empty, but it's possible, like for the second. So what's funny is this is actually going to work. This last one, this is the one that's throwing the exception, the error. Cool. So this is the test that has problems. This is the one that has the problem. The reason is array is not empty, so we don't return empty string. And we go through and we accumulate all the strings into list, but there aren't any strings in list. So we get the max of an empty list, which Max is upset about. So what I would do this check. I would actually do this. This is good in general to do, and I have said this explicitly, to do handle your edge cases first thing before your primary logic. And if I didn't say this before, if I misguided anybody about this, then that's on me. But in general, I also try to say when you can. So in this case, I think it actually would make sense to do this part of the logic first and then handle the edge case and then just base it on list, right? Because if list is empty at this point, we can just return empty string. So that's going to return empty string. So rather than handling this on array, we can handle this on list. We could also handle it on array up here too, right? Because if we have, a list of, 10 million numbers and there's no strings in it, then, maybe we don't want to run all this loopage to check for strings in a list, in a massive list that doesn't have any strings. So you might save yourself a little time by checking if array is empty up here too. So we could do that. I have a feeling there's like a more elegant way of doing this. But I'm going to submit this and just see if it works. We're just going to see if this is going to work. I didn't run all my tests. Oh well. This will run tests for me. Cool, that's going to work. Wonder if there's like a sleeker way of doing this. Okay. So what list is, it's just, I think I just pass a comprehension in here and just say, L, or let's say string, we'll just call it st. I'll just call it s for s in ARR if type s equals in stir. Okay. Okay, we'll just do this. Equals. Then I think we can get rid of this. The only problem is that it still could be empty. So we need to handle that before we get it to max. So we could just pop in a ternary here, I think, and just say if stir in Am I going to do another comprehension? Okay, this is just turning into a comprehension fiasco, but whatever. I feel like I'm committed to this at this point. If stir in type L for L in R keylen else that, I think. Okay, let's just try that. See if that's going to work. That works for that. And let's see if it works for these other two. Ugh. So it looks like it works. I did not intend for this to be such an atrocious solution. I thought it'd be cool, but this is a nightmare. Maybe I could do... No. That's fine. See if I can clean it up a little bit and still have it run. Okay. Whatever, we have an atrocious one-liner now. Code is not that pretty. It's concise, I guess, but... Okay, that works too. I'm not that happy with that solution, but... yeah, I think this is basically fine. Cool. Nice. All right. I'm not seeing any other questions. I did have somebody ask if I could go through number 4. I think they were talking about number 4 in this section, so I'm just going to go through number 4 just in case that's what they were talking about. Remove element. We'll call this one the last one, and we'll wrap up. So I'll close down. I'll close it down for new questions, and we'll just do this one. It was helpful to move the condition around. Good. Glad that was helpful for you. Okay. Cool. Write a function called remove element. What's it take? Given a list of elements, my list equals a list of... Oh, shoot. Here's a freaking... There we go. There's a test. I'm trying to write this test. Given a list of elements and a discarder parameter. Remove elements returns a list containing the items in the given list that do not match discarder parameter. Okay, returns a list. Doesn't need to be the same elements. If all the items match, it should return an empty list. Well, there you go. Let's check it out. Remove element. Def, remove element, takes in list. Dis I'm not gonna. I don't even like that. Discard. That's better. Discard. That's even better, actually, with all the letters that I intended. Okay, so we're gonna say let's call this in list, and we'll say list equals empty list. If no for L in list, if L equals discard we'll continue, otherwise we'll just list dot append L, and then we'll return list. Good, let's try that out. 131. Good, we got the right answer. So I think what I want to do is change all of these to 2s, because it did explicitly say if they all match, we should get an empty list, and we should get an empty list here. Of course, we get an empty list. Cool, I think there's multiple ways. There are definitely multiple ways of doing this. So what I did here is we go through the input list, which I'm calling in list, and then we see if the element in that list matches the discard parameter into the function. And if it does, we continue, which breaks. Continue skips the current iteration. It's just like, hey, don't execute any more code for this specific iteration. Don't execute any more code in the loop for this specific iteration. Just move to the next iteration. So it skips a trip through the loop. As soon as it hits that continue, it stops executing code in that loop. So if this is true, we're not going to do the append. Another way we could do this is just by saying if the element is not equal to discard, then we append. It might be simpler. Yeah, that's definitely simpler. Cool. So let's copy this, pop it in. This is, again, this is a kind of a boneheaded way of solving this. There's not much nuance. There are other ways of doing this. But the reason I'm showing this solution is to kind of showcase, like, with a simple set of tools and an approach of taking the approach of, like, making an additive solution. We start with something empty and we add to it under the appropriate condition. This approach just works. Let's try a different approach real quick. I think we can just say list equals in list dot copy. Probably don't have to do that, although it's best practice. So we're not mutating our input here. So list equals in list dot copy. Then we'll say list dot remove discard. I just learned about discard today for sets. I wonder if list has a discard parameter. I guess we can just, I'm just going to try it out. So in this case, we'll try to remove 3 and we'll see if it gives me an error. Oh, of course. So we do get an error there. Let's check this out. So we get that, and that's actually what we expect for this case. Oh, no. Nope. Definitely not the right thing. So we can say for blank in the range equal to list dot count discard. So for however many times discard appears in the list, we'll run the loop and we'll run that remove. So that should give me an empty list the second time, and we'll handle this value error. Oh, wow, that also solved the other problem. That also solved the value error. That's, well, shoot, I'll take it. Because if discard appears in there 0, this is going to be range 0, 0, which is not going to run any loops. Cool. I'll take that. Kind of disappointing because I was looking forward to seeing if list has discard. Oh, I guess I can just try it. Oh, right. Discard. Or how about that? Discard is not defined. Oh, I don't need to change it there because it's a property of list. Or it's not a property of list. List has no attribute discard. Wondering if there's something analogous though. Let's just do print dir list. I don't even need it, but I'm just curious. Okay. So we've got append, clear, copy, count, extend. No, I know there's no discard method. What am I talking about? Yep, no discard, alas. So we have to handle removes potential error in a different way, which fortunately this code happens to do, which is nice. Cool. I just want to submit it, see if that's going to work. I think it will. Unless I'm getting a curveball that I don't expect here, but we'll just see. We shall see. Cool. So both of those solutions work. All right, cool. Yeah, excellent. So that'll conclude study hall for today. Hopefully everybody found it entertaining and educational. I certainly do enjoy doing these. Let me know. Feel free to share any feedback with me. DM me on Slack. I know a few of you are waiting on a reply back. Apologies, I've just kind of been working with the backlog. But I'm going to have time to just power down pretty soon here and get back to people if you DM'd me on Slack. So, yeah, feel free to reach out. Feel free to share any thoughts or criticisms, helpful, friendly criticisms, whatever it is, just be nice about it. It's all good. I do want these study halls to be as good as they can be, and yeah. Awesome. So next study hall will be held on Friday of this week. And if you're in premium prep, then I'm teaching tonight, so I'll see you in there. Yeah, so that concludes study hall. Y'all have a good rest of your day. Bye-bye.